So, we're all trying to figure out how to build better AI, right? Not just AI that can predict things or generate cool images, but AI that actually, well, understands the world. This is where Agentic AI comes in. And today, we're going to break down the key design patterns that are making it happen.
Look, generative AI is incredible. We've all played with it. But let's be honest, we've also seen it get things spectacularly wrong. And that brings up a really important question. How can we build AI systems that we can genuinely trust with important stuff? That's the challenge we're diving into. Okay, first up, let's talk about AI's, let's call it a fact problem. You know those times an AI just confidently makes things up? It's often called hallucinating, and we're going to look at how to fix it. Imagine you ask an AI for a list of all the traffic laws in your state. It spits out something that looks absolutely perfect. But is it? Is it missing anything? Is every single point correct? Now the pressure's on you to go and manually check everything, which is slow, expensive, and kind of defeats the whole point. So the solution is a pretty cool pattern called autonomous self-RAG. Now, you might have heard of RAG. That's retrieval augmented generation. It basically lets an AI pull from external data to give better answers. Well, this takes it to a whole new level. We're talking about a self-correcting agent that acts like its own internal editor. It judges its own work and then goes out to find new information to make it better.
What's really fascinating is how this agent thinks. It's not just about spitting out an answer. First, it reflects, asking itself, is this actually complete and correct? Then it checks its own confidence level, like, am I really sure about this? If the answer's no, it decides it needs more info. But it doesn't just do a lazy search. It creates super specific queries to find exactly what's missing. Then it checks if that new info is legit, and finally, it weaves everything together for a much more accurate final answer.
At its core, this whole process comes down to the agent asking itself one simple but really powerful question. This is its mantra. It's not just generating, it's demanding proof for its own claims, just like a good human researcher would.
But of course, there's always a catch, right? All of this deep thinking and self-checking adds a lot of complexity. It takes more computing power, which costs more money, and yeah, it can slow the whole system down. So you're constantly trying to find that sweet spot between pinpoint accuracy and the need for speed.
All right, our next pattern tackles another huge pain point in the AI world, the incredibly slow and manual job of prepping data to train a model in the first place.
Yeah, before you can train an AI model, you have to prepare its food, which is the data. This whole process is called feature engineering. It's all about picking the right data points, tweaking them, and getting everything just right. It is so tedious and relies heavily on human guesswork, which can really slow down a project. So what's the Agentic solution? You guessed it. We bring in an autonomous agent that just takes over the whole job. It looks at the data and automatically finds, creates, and refines all the features needed to make the model as good as it can possibly be. It saves an unbelievable amount of time.
And this slide just lays it all out. The difference is night and day. The old manual way is slow and subjective. The new agentic process, it's fast, it's autonomous, and it's totally data-driven. The agent is only focused on one thing. Will this change actually improve the model's performance? That's all that matters. But here's the other side of that coin. In its mission to get the best performance, the agent can invent these super complex features that work brilliantly but are almost impossible for a person to understand. So we might get a smarter model, but we lose transparency. We can't really explain why it's making its decisions, which brings up that classic tension between raw power and our ability to understand it.
And that brings us to our final pattern, which deals with one of the most high-stakes issues out there, the danger of making a huge decision based on an AI prediction without knowing what will actually happen in the real world.
You know, an AI might predict that a new ad campaign will increase sales, but a prediction is just a correlation. It doesn't actually understand cause and effect. Just jumping in and acting on that prediction without understanding the why behind it, that can be incredibly risky, especially when there's big money or major outcomes at stake. This is where the causal inference pattern is a game changer. It basically gives the AI a lab coat and turns it into a scientist. Instead of just taking a prediction at face value, this agent designs and runs experiments to figure out the real cause and effect relationship before you make a big move. And the process is exactly what you'd expect from a scientist. First, the agent forms a hypothesis, something like, if we run this promotion, sales will go up by 10%. Then, it runs small, controlled experiments to test that idea, maybe showing the promo to just a small group of people. Finally, it analyzes the data to see the real causal link. Did the promotion actually cause the change we saw?
So the agent really has two types of logic working here. There's the statistical logic, which spots simple patterns. When it's sunny, people buy more ice cream. Easy enough. But then there's the causal logic, which goes deeper to understand the why. It's the heat from the sun that makes people want something cold. And knowing that difference is absolutely crucial for making smart decisions. But the major challenge here is that the design of the experiment is everything. What works in a small, controlled test might not work when you scale it up to millions of people. A badly designed experiment isn't just useless, it can be totally misleading and point you in the exact wrong direction on a massive scale. So, when you pull all of these patterns together, you don't just have a few clever tricks. What you have is a powerful toolkit for building AI that is way more robust, way more reliable, and just smarter.
So let's just do a super quick recap. We started with AI getting facts wrong, and the self-RAG pattern fixes that by delivering higher quality, more complete answers. Then we talked about the slow, tedious process of data prep, and automated feature engineering solves that for faster, better model training. And finally, to avoid making risky decisions based on shaky predictions, causal inference gives us safer, validated strategies. Each one solves a very real, very important problem.
And all of this leads to one final big thought. These patterns are pointing us toward a future where AI agents are much more autonomous. They can reason, they can self-correct, they can experiment. Which leaves us with a pretty fascinating question to think about. As these AI systems start doing more of the complex work, what does our role become? I think that's something we're all going to be figuring out together. Thanks for listening.